let's take a look at the idea of scalar multiplication. If c is a scalar, saying that c is a scalar is saying simply that c is an element of the real numbers. It's simply a real number. And v is a vector. Then the scalar multiple c times this vector v is a vector whose length is the absolute value of c times the length of v. Again, v is this vector. And whose direction is the same as the vector v if c is positive, and it's opposite in direction if c is negative. And obviously if c is 0 or if the vector v is 0, then cv is also going to be 0. So let's take a look at what that means. If I have vector v, let's say this is v, then twice v, here c equals 2, is going to be a vector in the exact same direction. Now that's supposed to be the same length, so what I'm going to do is double that length. So there's my new vector. So this would be twice v. Now if I multiply it by negative 2, so negative 2v would be this same vector but opposite in direction. So it would be, to the best of my ability to draw it, same length, which is twice the length of this one, but again it's in opposite in direction. Now this idea leads us to the idea of being able to subtract vectors, the difference between two vectors. So if I have vector u and I want to subtract vector v, this is equivalent to taking u and adding -1 times vector v. So let's take a look at u. See, that's vector u. And I want to add to it vector v. So let's say that this is vector v. Well, if I'm going to add those vectors, all I have to do, oops, I missed. Let me see here. If I can grab that guy. There we go. That would be the addition. If I take a look at this vector, this is vector u plus v. But what happens if I take a look at the negative of v? Well, if I do the negative of v, that's going to take this in the opposite direction. Let me see if I can get this. That's a little bit ugly. I just flipped it around. So if I take the opposite of it and I add it to it, this is the subtraction. So now u minus v would be here. This is u minus v. Or another way I could have looked at this, let's see if I can grab this, put this over here for a second, and then I'm going to try to draw this vector v again. Another way I can think about this is if I simply take and put the heads together. That would then again give me the same vector, which is u minus v, which is u plus -1 times v. So now let's consider a minus 2b given, let's see, a equals, let's see, a vector like this, and vector b, let's just say, is a vector that looks like this. Now negative 2b, negative 2 times vector b, again all these are vectors, would be a vector that's twice this length but opposite in direction, so roughly something like that. maybe a little bit longer. I'm just eyeballing this. Obviously, I don't have a grid going here. So a minus 2b would be this vector. Here's a minus 2b. This is vector a. This is vector negative 2b, a negative 2 times b. And then, of course, when I add them together, I get this vector, which is a minus 2b.